A point source of light lies at the bottom of a pool of water 2 meters deep. A thin cork mat floats on the water with its center directly above the source. Find the minimum size of the mat such that an observer above the surface cannot see the light. When we say that an observer above the surface cannot see the light, what that's trying to tell you is that we want to find how big does the mat have to be so that any light rays that would potentially go past the mat will instead be reflected back into the water. And so we would have to find, to start off, the critical angle of this interface, which would be right here. And we can use Snell's law / the critical angle formula to calculate this. So n times the sine of theta c equals n prime times the sine of 90. And we know that we can simplify that to say the sine of theta c equals n prime over n, because the sine of 90 is 1. And what is our n prime, what is our n? The light is starting off in the water, so your n is equal to 1.33, and then the air above the water is your n prime, which is 1.0. So to plug into our formula to find theta c, the sine of theta c is 1 over 1.33. Then we can solve for theta c, and the critical angle is going to be 48.75 degrees. There are a few ways that you can go about solving the problem from here. We are told that the source is 2 meters below the surface. And so you can see we're forming a triangle here. The 48.75 degrees that we just found here for the critical angle would be equal to the angle here. And so we can use these measurements to find the length from the center of the mat to the edge of the mat, the edge of the triangle. So we know the size of the angle, the degrees of the angle. We know the length of the side adjacent to the angle, and we are trying to find the length of the side opposite of the angle. And I don't know how many of you remember this from geometry. SOHCAHTOA. And so this means that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So for us, we are trying to find the opposite, and we are given the adjacent, so we know that the tangent of 48.75 degrees is equal to x, the opposite, over 2 meters, the adjacent length. And now you can solve for x, and you would find that x is equal to 2.28 meters. So to find the minimum size of the mat, you would have to multiply x by 2 to get this entire length. And so the length of the mat would be 2x, which is 4.56 meters. And if you just think about if the mat were any smaller, then a light ray would be able to pass at a smaller angle at the interface. If the angle was any smaller, it would be smaller than the critical angle. and if an incident angle is smaller than the critical angle, then some of the light would be refracted to the other surface, or into the other medium. And so an observer could potentially see that light from the second medium. But instead, the only light that can potentially get past this mat has to travel at least at 48.75 degrees, and since that's the critical angle, none of light will be refracted into the second medium, and no light will be seen by any observer above the surface.